All right, so what was I talking about? So over the break, I am gonna have some things you'll need to watch because I'm really getting worried about time. We have 2 more units after this. And so I'm definitely gonna finish up the rest of this packet and put it in there. I will also go over the quiz via recording and also our test. Glenn just finished that test that y'all did, I think last week. And so I'll get those graded, and I'll probably put in all of those things. And then our next little packet is called buffers, and I probably will also have you watch on that too. And then whenever we come back, if you have questions, then we can go over them at that time. And then that leaves us with another pretty hard unit, and then an electrochemistry unit that's really short, a short unit. I just want to give us some time, make sure we have time to review. All righty, let's see where we're at. Okay, so nobody had anything on the part where they watched? All right, then we're not really gonna do that many notes today. And then if you have any questions on any of the practice, then you can also ask those. There is some on the practice that, if you've looked at the practice, if you saw any with a KB, we hadn't gotten to those yet. So that's obviously gonna be the KB for the base, but there were some ones on there. There was some that we won't even get, that I marked out that we will not be ready for the quiz. Can't remember what it was exactly. It's on, let's see which paper. It's on this paper that says AP acids and bases, and the back of the first page, that E, all through that whole page, that's something we haven't covered and we won't get covered today. I think everything else was pretty well, we have covered or we're going to cover it today. All righty, let me find out where we're going to go then. Oh, we can start right here, maybe. All right. So you don't have this slide. It's just a little question. All right. So this is a diagram, and it's asking, so this might be something you would see on a multiple choice question. And it's asking, what is the percent ionization of that weak acid? So percent ionization was one of the things that we covered on the video. And if you remember, your percent ionization was going to be your conjugate base. So that would be on your product side. Divided the concentration of that divided by the concentration of the, not the number. In this particular one, we won't have a concentration where you can count up particles, but it'll work the same thing. Divided by the concentration of the acid at the beginning. And then times 100. Anybody got any takers? Any guess? Nobody? I'm gonna tell you, when I saw it, I picked up the wrong answer the first time. Yes, I did. It is 25%. I picked out 33% because I just quickly said 2, because I had my 2 red ones. Those were what they disassociated to, and I divided it by what, 1, 2, 4, 5, 6. But that gave me 33%. And what I forgot was these 2 red ones, because this is the original concentration. They also would have originally been part of that concentration too. So you really needed to do 2 divided by 8, if I can count correctly, or 8. So that's where you end up getting your 25%. Yes, ma'am. How's it what? Because whatever it was, like we'll just say HA for weak acid. And then this was originally H2O. And then when it ionized, not very much. Remember, by definition, the acid is a proton donor and the base is a proton acceptor. So that means this became A minus, which that would have been my conjugate base. Because if this was my acid, once it lost the hydrogen, then this would be my conjugate base. So that's how that one would end up. And then you would have your plus H3O plus. And since, let's see, yeah, since this was accepting a hydrogen, it was acting as a base here. So this becomes its conjugate acid. So we were looking at the concentration of this divided by the original. And what you had to do, if you just looked at it real quick, you would have just taken the two red ones and divided it by any of these that were left. But you had to remember that originally those would have been part of the product to begin with. So that was just kind of a little tricky one on that. All right, and then one more that is easier. If you were given the Ka values with the formula and this phosphoric acid, which of the following shows the correct relationship among the Ka values? It has 3 Ka values because that acid has 3 hydrogen. So remember it has to be C. Because my Ka, that first one is when I go, oops, I can't write today. I lose 1 hydrogen. So that's going to always be my strongest. So that's going to be my largest value. And then each time it loses another. So this one would be for my second hydrogen. That becomes HPO4 minus 2, and that is a little less ionized, so the Ka would be a little bit smaller. So that's what that one is. You just got the larger the Ka, the more that it ionizes. All righty, let me see where we're at these notes. All right, so we're going to talk a little bit about bases. We're not going to talk about a whole lot about them. So remember, when we talk about bases, we're usually talking about a hydroxide group is either part of it to begin with, or it ends up producing hydroxide groups when it's combined with water. So our strong bases are group 1 and group 2A metals from calcium on down. So that means beryllium hydroxide and magnesium hydroxide are not considered strong acids. And remember, all it means is if it's not strong acid, I'm sure I'm going to do that. A strong base. All it means is if it's a strong base, is that it's going to ionize about 100%. So these ions would be greater. I have a little difficulty writing today. These ions would be greater than the original. If it was weak, so we'll just use beryllium hydroxide, it would ionize into Be2 plus 2 hydroxides, but not to very much extent. So now your arrow, not your arrow, I guess the head of your arrow, your equals, your greater than would be toward the reactant. That's all it means whenever we're talking about whether something's a strong base or a strong acid. All right, so this one's pretty easy because sodium hydroxide is a strong base. So if I know that my beginning sodium hydroxide has a concentration of 0.100 molar, then so do the ions because it ionizes about 100%. So those are my easy ones. I don't have to do a rice table. All right, so that gives me my hydroxide concentration. Remember, this is hydroxide. So if I take the negative log of that, that's not going to give me my pH. That's going to give me my POH. So remember, and we did this in Chem 1 too. If you have a base, you're going to have to get your POH first and then subtract from 14. So I'm going to do my POH is going to be equal to the negative log of my hydroxide concentration. And that is 2.000. So if that's 2.000, then my pH is going to be 14 minus that. 12. So that is my pH. And remember, this was 3 sig fig, so that's why I'm keeping 3 places. And then I want my hydrogen ion concentration. So to do that, I think this is a formula that is not on y'all's screen sheet. I'm going to take 10 and raise it up to my pH. And it should be a negative pH, I'm sorry. And when I do that, I'm going to get 1 times 10 to the negative 12 molar. It's going to be my hydrogen ion concentration. So those are the nice, easy ones. Of course, you probably won't get to see too many of those on the AP test because they like to put the harder ones. So we're going to look at those. It's very similar to calculating the pH of as far as the setup, very similar to calculating the pH of a weak base, or I'm sorry, weak acid. Just at the end, you have to remember that what you figured out, yeah, because like that's a real common mistake that people get in a hurry. And what you can figure out at the end, because you have your hydroxide concentration, then people do the negative log of that, so that's the pH. So you put all that work into it, and then you make that mistake at the end. So just like our other one, we will need a rice table. We can ignore our X most of the time. And we'll see after the setup, it's going to look very much like our acids. So weak bases. Let's ask Mrs. Parker a question. Weak bases, which would be our bases without hydroxide, react with water to produce a hydroxide. And so these are the common ones that you'll probably see. Ammonia, NH3 is very common. Methylene and ethylamine, I guess. I'm not for sure if I'm pronouncing that right. Those are going to be that very common weak bases. So we'll just take ammonia. If we react that with water, one of the hydrogens is going to come over here. So I end up with ammonium and then a hydroxide left. So that's how it produces its hydroxide. This one right here would be once it got a hydrogen, it would become CH3NH3. Sometimes and I'm just writing these in case you're wondering where the hydrogen would go. You know, is it going to go with this hydrogen or this hydrogen? It's going to go with the one at the end. And this would become C2H5NH3 plus when it received the hydrogen. So those would be the conjugates of that. So just looking at some setups here, if we have our base and we put it in water, then like I said, the water is going to give up its hydrogen. So that's why it's acting as an acid. And then you're going to end up with some hydroxide, and that's why we call it a base. So here is our weak, I cannot quit saying acid, our weak base, NH3 ammonia. Gains a hydrogen, I end up having ammonium, which would be my conjugate acid. Since water acted as an acid, the hydroxide becomes my conjugate base. Most weak bases that we use or that you see involve some kind of nitrogen. If you go back and look at all three of those we talked about, it involves some kind of nitrogen. And the reason that is nitrogen has those three lone pairs of electrons, those three lone electrons, so it's easy for it to form three bonds. So that's what it did in each one of those. All righty, any question on that? All right. So the base dissociation constant, so this is just set up, it's just coming from that equation that's on the bottom of the other page. You see it's very much like what we do with our acids. We still have our reactants on the top and our products on the top and our reactants on the bottom. So that's just like our acids. So like I said, if we're working with the weak base, it's going to be a whole lot like a weak acid, but especially remember that you are going to get the POH first and then subtract that to 14 to get the pH. Because if you set up a rice table and do all that work, I would be really frustrated with myself about that. And remember, pH plus POH equals 14. So that's the little one that we can use. All righty, let's look at a couple of these. I'm going to do one with the rice table and then one without. All right, so we're calculating the hydroxide and the pH. Notice it doesn't say POH of a 15 molar ammonia solution. So that's a weak base. And then they give me my KB because it's a base. So I'm going to just have, I'll start with my R, which would be my reaction, NH3. And this is a reversible reaction, is going to become NH4 plus OH minus. Kind of like with acids, the water is usually left out of there, kind of just assumed. All right, so initially this is 15 molar. This is pretty strong molarity. And there's not in either of the other two at all, because this isn't like sodium hydroxide. I can't say, well, if I know this is 15 molar, then I know these are also. So this is 15 molar, this is X, this is X. And then we're going to do our change. So they're all on a 1-to-1 mole ratio. So this is minus X. I'm sorry, y'all. These should have been zeros. Plus X and plus X. So that means at equilibrium, I'm going to have 15 minus X. This is just X, and this is just X. So we have our 1.8 times 10 to the negative fifth, and it's going to be about equal. And you may choose that to do that on your AP test, put that little about sign to show that you know that we're dropping the X. So it's going to be about equal to X squared, because that's what I have as my products, divided by, like I said, we're going to ignore X, so just divide it by 15. So you take your 15 up, and then you have to do the square root. So I got X is equal to 0.0164. All right. And that is my hydroxide concentration. That was one of my questions. Now I need to find the pH. So I'm going to take the negative log of my hydroxide concentration, but that's going to give me the POH. So 1.785. All right, and then to do my last step, I just need to subtract that from 14. So I'm gonna take 14 minus my 1.785, and then that gives me my pH. 12.2215. And this was 3 sig figs, so that's why I'm keeping my pH with 3 numbers behind the decimal. This concentration, because when I figured out what X was, that was the hydroxide concentration. So if I took the negative log of that, that gave me my POH, which was this. And then since I wanted my pH, that's why I had to subtract it. So pH doesn't have units, obviously, but you want to kind of be sure that you label it, especially if you get your POH first, and then you do that last little thing to get your pH. You want to make sure that you know, pH so they can see that you realized that that was what you had to do to finish that problem up. All right, the next one I'm going to have y'all try. Maybe. Oops, no, we're not doing salts today. All right. Oh, I guess there's not another one on there. Did I pass it by? Oh, yep, I sure did. So methylamine, I don't have it memorized. It's back on the other page, but I'll write it down for y'all so y'all don't have to flip. All right, so that's your methylamine. And what are we doing for this one? Just the pH is all you have to come up with today. Anybody got a pH? 12 point what? I'm sorry. That's what I got. 12.32. Anybody else have 12.32? All right. Hey. So this one says it's on a 1-to-1 mole ratio, kind of like we did our weak acids. After we have done a few, you can set up a rice table, but it's going to end up being 4.38. My KB times 10 to the negative 4th is going to be X squared divided by my original concentration. And this is kind of on the brink of whether you should do a quadratic or not. But if you go all the way to the end and figure out your X, you'll find out that it's not, it is still less than 5%. But we're kind of getting a little bit close there. So here, if I do all my work and I take the square root, I end up with an X is equal to 0.021 molar. And my X is my hydroxide concentration. When we were doing acids, that would have been my hydronium concentration. So if I do a real quick one, I see that it's less than 5%. So if I just do a quick 0.21, no, 0.021, that would make a difference, wouldn't it? So what I get my X, if I come and I divide it by my original concentration, I think I got, yeah, you end up getting, and times 100, you end up getting 2.1%. So you're fine, because our rule is it needs to be less than 5%. So I'm telling you on the quiz, there's not going to be any quadratics. When we have the test, I'll tell you whether there might be a quadratic or not. I usually don't do them because I don't know how to get it into my calculator like y'all do. The people that I talked to on the AP test say that there hadn't been a quadratic on the AP in years. So we're going to cross our fingers and hope that they keep that. It takes a while to do them, and since it's timed, it kind of takes a lot of your time. You would on the FRQ, but yeah. So why do we learn it? Well, we learn it because it is always a possibility to be there, but some of y'all still may take chemistry again in college for whatever reason, if you don't pass or if you just choose to, and so you probably would see it then. All right, we're not finished because I need my pH, so I'm gonna have to get my POH first, which would be the negative log of 0.021, which I think I got 1.68. And then I actually still want my pH. So I'm going to take 14 minus 1.68, and that's where I'm going to end up getting my 12.32. All righty, questions on that one? On the quiz, there's at least one problem like that, maybe more than one. I'll look at it. We have to do a rice table. All right, we're going to stop there. The next thing is determination of pH salts. And that has always been hard for me, myself. And so I really need to go back over my notes a little bit better than I had a chance to before I do that. So that will be part of the part that I record whenever y'all are on spring break. All right, we're going to stop there. If you have any questions over any of the practice, now would be a good opportunity, or questions over anything else. We can handle all those things now. And I'm going to remember to